right, so I'm here to talk to you about building an open source cloud. I've got 20 minutes, so you won't actually be able to build one by the end of this talk. But I'm hoping to point you in the right direction so you sort of know what tooling you're going to need when you embark on this. So first, I'm going to explain what I mean by cloud. So you saw yesterday with the Kubernetes demo, there was a Google Cloud, and then a lot of you, I'm sure, are very familiar with Amazon clouds. The idea is if you want to stop using a third party, you can start building a cloud internally. And that is what OpenStack is. Who here is familiar with the OpenStack project? All right, that's a pretty good chunk of the audience. So OpenStack was founded in 2010, which makes it a pretty young project for a massive infrastructure project. And it's written to build clouds. It's written in Python. There are a variety of reasons for that. One of them is that it's a lot easier to write in than Java, which some previous open source clouds have been written in. What a lot of people don't really realize from the outside of OpenStack is it's actually made up of hundreds of projects. There are over 1,000 projects in the repositories that we maintain now, and these are projects that allow you to modularly build your cloud. So you can add networking and compute sections to your cloud, which are pretty standard. And then on top of that, you can do things like block storage, object storage, and then add a bunch of different things like databases as a service, DNS as a service, and the number of projects is always growing. In this infrastructure that sort of is the OpenStack project, there is also this vast marketplace of vendors. This has been the truth since pretty much the beginning of the project. You have companies like my employer, Hewlett-Packard Enterprise, and then a bunch of our competitors all getting together to work on this project. So there's this huge marketplace of vendors who will do everything from telling you how to do really basic stuff in OpenStack and being just on call if you need some help with your deployment, to actually buying a data center and pretty much rolling in and installing OpenStack for you and managing it completely. So you have a lot of options in this vendor ecosystem. But what I'm here to tell you is that OpenStack has matured enough today that you don't necessarily need that. Don't tell my employer. So a little bit about me. As the introduction said, I'm an automation and tools engineer at HP. I was hired to work directly on the open source OpenStack project. So we, in the team that I work on, we run the infrastructure for the project. That means we run the continuous integration system, all the wikis and the bots and the etherpads and everything that developers interact with on a day-to-day basis. I joined that team in 2013, and that's what I was specifically hired to do. So I don't actually do anything at HPE. I'm fully upstream. I also wrote a book. You mentioned I am an author. It's coming out in September about different types of OpenStack deployments. So as I started sort of preparing for giving this talk and getting a deeper understanding in some of the projects that we're working on about what kinds of OpenStack clouds are out there, I was able to interview several companies who are running OpenStack. Part of this was sort of to get an idea of what sort of OpenStack clouds are out there, what components people are using. Another part of it was that in the OpenStack infrastructure team, we are the users of a lot of clouds. All the tests that we run on all of the development changes in OpenStack are using OpenStack clouds that are provided to us by vendors. So these are public clouds that we're interfacing with that are all running OpenStack. This has led us to discover a lot of different things about OpenStack and about how it can be configured. Every vendor that we work with provides different services. Some of them are fully open source and part of OpenStack. Some of them are proprietary services. The DNS that we use is a proprietary service, but the MySQL database as a service tooling that we use is open source. So different companies are choosing different infrastructures and different parts of the infrastructure to build their clouds. Additionally, we started an infra-cloud project so that we would no longer just be a consumer of other people's clouds. We were given a rack of hardware by HPE and said, here's a rack of hardware in a data center. You can install OpenStack on it if you want and run tests. So we did a sprint earlier this year where we actually got that running, and promptly they moved all of our stuff to another data center, which was in Houston and flooded. And so we've sort of had a rough time of our infra-cloud project. But the point is we actually did build an OpenStack cloud, and we're getting back on our feet there. And so one of the really important things that I've learned in this is that configuration management is super important to the maturity of this project. So, as I mentioned, we're not going to completely build a cloud today, but I do want to give you some pointers and things you're going to consider if you're starting to build one. So, installing OpenStack used to be really, really hard. Even today, the install documentation for OpenStack doesn't really mention configuration management. They say, type this MySQL command, edit this config file. And if anyone is doing that sort of thing in production these days, I'm sorry. You really want to be using configuration management and tooling that allows you to never, ever touch the MySQL command line ever again, which is a lovely tool. But in production, you really don't want to be using something like that. It's error-prone, and you really don't want to be wasting your time configuring simple things like MySQL or a queuing service or Apache. That has all been automated for you already, and there are lots of Puppet modules and lots of availability out there, so you don't have to worry about these simple things anymore. Also, early days of OpenStack, a lot of the configuration tooling was proprietary and very like vendor and distribution dependent. So you'd go to a company like Red Hat or Canonical. Red Hat would give you Red Hat OpenStack, Canonical would give you Ubuntu OpenStack, and their tooling was crafted very specifically towards those different operating systems. A lot of the tooling early on was also proprietary, so you couldn't really build your open source cloud unless you were willing to run those MySQL commands, write your own scripts, write your own modules. So in the configuration management space, there are 4 key configuration management systems that are now in the OpenStack tree. I mentioned those thousands of projects, and these are in that thousands of projects collection. So I gave example names here for sort of what you'd be looking for in this git.openstack.org list. So for Puppet, you have Puppet modules, and they're sort of named with Puppet and then the service name. Your Chef cookbooks have a name similar to this, so they're seeing like OpenStack Compute rather than the project name of Nova. The Ansible playbooks have another format, Juju Charms yet another. So once you pick your configuration management system, you can go to git.openstack.org and find the components that you want to use in your cloud. So whether it's compute or networking, DNS, and various things. But let's be honest, installing OpenStack is still really hard. Having configuration management is really only part of the story. You still need to make a lot of decisions about what your cloud is going to do and who is going to do that. So you first need to build a team. This team needs a few key people in it. You need some really strong systems administrators who know a lot about Linux. These people need to be able to dig down into stack traces, know a lot about networking tools, so that when networking stuff goes wrong, you can actually talk to your network administrator in a way that makes sense to them. You need to be able to read log files, look at Python bugs and stack and the errors to then talk to your Python developers about what's gone wrong. Ultimately, you need to know about scaling and coming up with backup plans, and in general, just being really knowledgeable about how to build a large infrastructure that has a lot of fault tolerance and people are really depending on. You also need some network engineers. One of the things with OpenStack is that it's super flexible when it comes to networking, which is great, but it means it's really hard to have a reference deployment. The documentation gives you a few options, so it gives you a few demonstrations of things you might want to do with networking, but you have a whole lot of options, which I'll talk about in a little bit. So you definitely want to have someone who's really good at networking on your team who can make intelligent decisions there. The next one I learned sort of the hard way. You want to have a really good relationship with your data center techs. They're the ones who are there with your computers, and since OpenStack is very modular, you'll find a lot of your services live on different machines. So as you're working through that, getting the fault tolerance up and making sure that your system is fully HA, being able to contact those people and sort of know who they are rather than just submitting tickets is going to be super helpful. Because you learn that you sort of speak a different language than the data center techs. They know a lot about hardware, they know a lot about the infrastructure physically on there, but you've never seen these servers, and you need to be able to make sure you understand how to speak to them and say what server is in what rack and exactly what needs to be done, especially when it comes to some of the networking hardware changes you need to make. And finally, you probably want to have some developers on staff who are knowledgeable with Python. OpenStack, as I said, is completely written in Python, and I can guarantee you that you will run into some Python errors while running OpenStack. Not because OpenStack is bad or immature, but because you are doing interesting things with it that other people may not have done before. So there'll definitely be things that pop up. There are bugs that come along, as in any software, especially something as big as OpenStack. And you'll want people who are contributing upstream, which I'll talk about at the end. So I'm talking about building an open source cloud here with OpenStack, but a lot of what I'm going to be talking about sort of is applicable to any sort of cloud or virtualization technology that you're going to deploy anywhere. First, you need to decide why you're using this cloud. Are you replacing another tool, and what is necessary for that? Or are you building a new infrastructure, and you need to understand from your users what they're going to need? For instance, do you need a lot of compute power, which means a lot of processor and RAM? Are you processing a lot of data? Do you need a lot of storage space? What kind of storage space do you want? Do you want that just to be files dumped on a file system, or do you want them accessible through some replicated object storage? And then you sort of need to make decisions about speed and reliability. You can have either one, or you can have both, but there's going to be costs involved with these. So of course your boss is going to say they want it to be fast and reliable, but you need to be realistic about what you can accomplish and what actually makes sense for the business, and then have the right conversations about that so you can plan accordingly. So one of the huge things that I've run into over and over again in doing these deployments is being really smart about how you plan for your networking configuration. This is something that's really hard to change later, but it's really hard to plan for because you're not really sure in the beginning what you're going to need networking-wise. And OpenStack has so many options for networking that it can be a bit overwhelming, which is why I really want you to have a network engineer on your team. So what you first want to do is make some decisions around the sort of access you want to your servers that are being spun up in OpenStack. Do you want them to have a public IP address natively, or do you want to be able to assign that public IP address? Do you want them to be able to talk to each other directly, and how fast do you want them to be able to talk to each other? Because that will change how you do your internal networking, whether you're using Open vSwitch or Linux bridging, and how these systems talk to each other. And then, are you using a lot of physical hardware that OpenStack hooks into with the plugins? So do you have a bunch of switches and routers that you're going to use with OpenStack? Are you using VLANs or VXLANs? You end up with a lot of questions that you need to answer when you start diving into networking. And these things are really hard to change later because people start relying on it. They start building their tooling with certain expectations, like they expect to have a private IP address, or they expect to be able to have a native public IP address. And in this, you also want to put a large amount of time into thinking about security. If you're processing a lot of data and dumping that into a database that's then accessed by other machines, the machines doing the data processing probably don't need internet access. So you want to lock that down and make sure that they only have access to what they absolutely need to. This will be a huge help in your security profile in your organization, but also just in general, like reducing the burden on your network. I mean, if things don't need the network, you shouldn't give them the network. And then you also want to think up what sort of backup strategy you want to have. If you're running a lot of compute instances that are only processing data, you probably don't want to back up those instances. Those instances will be treated as ephemeral. You can kill one, and another one will pick up in its place and start feeding the data into the data store, whether it's a file system or a database. So you don't want to back up your instances, because that would be a waste of time and a waste of resources. You do want to make sure you have replication on your databases, that your block storage base has some sort of replication across it, whether you're using RAID or a NAS or whatnot. The object storage component of OpenStack has fault tolerance built into it, so you want to make some important decisions if you're using object storage about what kind of configuration you want there for that. You also want to think about where your backups live. In a perfect world, we all have our backups off-site, so when things go wrong, you're not really in trouble in a huge way. But you have to consider what kind of bandwidth you have, how realistic is it to have up-to-the-minute backups off-site, and then what backups you can have on-site and transfer them to off-site. But what I've learned with OpenStack is that as soon as an OpenStack instance is deployed inside of an organization, people start using it and relying on it really fast. And if you don't have backups from day one, people get really, really grumpy when things go wrong. You also want to consider failover. You'll need to think about how you're structuring your OpenStack deployment, or really any cloud deployment. I've seen so many people deploy in one region, so either whether it be a data center or a single rack, and they use a lot of the OpenStack defaults. So you'll always know what region was your initial region, because it has all the default names in it. And then the second region actually has like region 2 names. But you probably want to think about this before you use all the defaults on your first region. So think about region, and thinking about scaling early on is really important when you're trying to start this out. There's also the idea of having automatic or manual failover. Again, in a perfect world, we all want automatic failover. We never want to get called in the middle of the night. We want everything to work perfectly and fail over automatically. But that has a huge cost to it. Even though OpenStack is built to be highly available, you have a lot of fault tolerance that needs to be checked. You need to make sure it doesn't get split brain, like not knowing who is the master between your regions. You need to do a lot of testing. So early on, a lot of deployments end up being quite manual, and then you start automating the really simple things when it comes to failover. And I wanted to spend the last few minutes here to talk about contributing to open source. This is a very open source conference here, so it may be a lot of repeat for a lot of you. But in almost every OpenStack deployment I've seen, companies want to do the really simple thing of just patching things inside of their own infrastructure. They don't want to deal with the upstream OpenStack project. They just want to patch it and then get back to work. I think we all know the technical debt that this causes, but it's magnified even more in a project like OpenStack. OpenStack is huge, it has a lot of components, and it's developed really, really fast by these hundreds of companies who are working on it. So there's a release every 6 months, and a lot changes in those 6 months. So the chances of your patch that you applied in the version that you're running in production, applying in the next version of OpenStack, become smaller and smaller with each version that comes out. And significantly so in a project like OpenStack. So you don't really want to be carrying all those local patches, and you want to engage with the community, even though it takes longer. And this is going to be a hard sell to bosses, because they just want to get their work done and say, like, just fix it and move on. But that team of Python developers on your team should also probably be the ones, your liaisons to the open source project in OpenStack. They should be committing the changes that you're making internally to your internal product. They should be working with the OpenStack community to make sure that features that you have in OpenStack and that you're using in your organization are remaining in OpenStack and are maintained. And that may mean adding more developers onto it to work upstream. But avoiding this technical debt is a huge, huge thing. The other thing I'll mention, because it's my baby and it's my project, of course I work on the continuous integration system for OpenStack. And just like we heard about Rust yesterday, we test all of the changes before they land in our Git repository. This has been important to us from the beginning, because we have hundreds of companies working on OpenStack. A lot of those companies are competitors. So if I landed a bad patch and I'm at HP, the person over there who's working at IBM is not going to be happy. Really, like, when competitors stall each other on a project, that is like the recipe for disaster. So we want to make sure everything is tested. And by contributing to upstream, you get to take advantage of that testing infrastructure. So we're running a bunch of continuous integration testing on everything, making sure everything is passing for the basic things that we test, in doing unit testing, functional testing, and then integration testing, so that even if you're just working on a really small component of OpenStack, you end up sure that it doesn't break another part. So you submit code to, say, the compute module of OpenStack, and then you're like, I only work on compute, I don't know anything about networking. But the CI system will test it against networking, so that you can be sure that your patch didn't break something in someone else's project. So in addition to all the robots that we have making sure your code is good, you also have the expertise of experts in the community who are reviewing your code. By policy, we need 2 reviewers to review your code before it can be approved. So you have 2 people who know about scaling, who understand the OpenStack infrastructure, and can review your patch and offer guidance to help improve that. If you want to add a new feature, these same people are also there to help guide you to what makes sense for the OpenStack project, what is going to be maintainable long term. So my last slide here is just a picture of our code review system. It's called Garrett. It's developed by Google. There's a lot of stuff on this slide, and later you can follow this link to sort of see what's going on in this review. But I submitted this review to the Puppet config while I was working on the Puppet stuff to get our deployments running. And you can go through this review and see the conversation we had and the bunch of tests that were run and the reporting on those tests. So I'll be around at lunchtime and the rest of the day. If anyone has any questions, wants to chat, say hello. I'm very shy, so please say hello. Thank you.